Hi! In this video we are going to analyze a problem that comes directly from our lecture notes, and it's the chocolate bars problem. So in this problem we have a package and we want to put chocolates inside this package, and this package has a number of kilos we need to achieve, and we can put chocolates there that come from big bars of chocolate or small bars of chocolate. Big bars of chocolate are 5 kilos each, the small bars of chocolate are 1 kilo each, and we need to put as many big bars as possible before starting to use the small bars. The program at the end needs to return the number of small bars we had to use, or -1 if there's no solution. It's not possible to do the package that we want, given of course the inputs that we have, right? The number of small bars and the big bars that we have and the total number of kilos we want in the package. So let's do the variable analysis, and we have 3 input variables: the small bars, the big bars, and the total number of kilos in the package. They are all integer, they range from 0 to infinite. And as an output variable, it's the number of used small bars, it's an integer, it ranges from 0 to infinite as well. When we look at the dependencies among these variables, we don't see any, right? I mean, they're all independent from each other, in the sense that one doesn't really change the range of the other. However, there's this constraint, that is, we need to use the big bars before the small bars. And then let's do the equivalence partitioning and boundary analysis. And this one is a bit different from the previous exercises because we cannot really leverage on the range of the variables, for example, as we could before, right? Because for now it's from 0 to infinity. I mean, it doesn't really help us so much. This constraint is also a bit tricky to model in a mathematical way. So my suggestion in this case is for us to then look at the output variable and how the input variable can influence it. And if we pay attention to the problem, we see that the number of small bars and the number of big bars are the ones that play the big role in there, right? So supposing we have a valid number of total kilos that we want, then the small bars and the big bars are the ones that play a big role there. So what I did was I started to think of how these two variables, the small bars and the big bars, could play a role in the output. And then I observed that there might be outputs that are composed by means of only small bars. Other solutions are composed by only big bars. Others are a mix of both. And other solutions are simply not possible because we don't have enough bars. So I just drew a simple picture like the one you see here. Each box is a class, and I started to draw arrows to then analyze the boundaries. So for example, I noticed that it's possible to have an input where the program returns -1 because there are not enough bars, but we change it just a little bit so that we can then have a solution that is composed by only small bars, or only by big bars, or only by small bars or big bars. Or from the small plus big bars class, if we do a small change, there's a boundary there that then makes the solution to be only with big bars or only with small bars. So this was my line of thinking. And if we then transform these back to the equivalence partitioning table, so these are the boxes there are the 4 partitions that we observe, and the boundaries are basically the arrows, right? So we have 1, 2, 3, 4, 5 arrows, and they're 2 sides, so at the end we have 10 here. I even grouped them, I gave them numbers because they have a relation, right? Both sides are basically the same test, right? So if I exercise this boundary here, for example, only big bars going to small bars and big bars, maybe the test I devised for these already exercises the other way around. So small and big bars going to only big bars. And then my test strategy was to test them all. So we have 5 arrows, 2 tests for per arrow, so for each side of the arrow, and then we can see the 10 tests here, right? So these are the first 10 tests. But then I also observed that when going from not enough bars to small and big bars, there are two ways to do this, or there are two boundaries kind of there, which is uh, it can be that the big is the input that changes from not enough bars to small and big bars, or it can be the number of small bars that actually make it to go from not enough bars to small and big bars, right? So these two inputs are the ones that influence. So it's plus two tests to test this other side of the of this specific boundary. Yeah.